Hey folks, welcome back to the channel. Today we'll be working on the problem encode and decode strings. So let's see what the problem description is. So the task is this. You're given a list of strings and you need to combine them into a single string. This is encoding. And later you take that single string and you need to convert that back into the same exact list of strings. This is called decoding. So for an example, let us say if you have hello and world as your list of strings, you need to do encoding and do these two words as one string. You need to return one string. That part is encoding. You can do whatever, you can choose any method to encode it, right? And once you get this string, you need to decode it and get back the same list again. That's the problem description. Now let's take an example and see how we can build solution around this problem. So let's start simple. Let us think that the list of strings that we have is this list. Let us say we have this string and we have this string and we have maybe this string. So you might think, why not just join these strings using a comma? That's what we have to do, right? We have to take this list of strings and we want to turn it into one string. So what you can think of is, take your first string here, data, use a comma as a delimiter, then take your second string, 1, 2, 3, use comma as delimiter again, and the third string. You can return this single string as your encoded string. Pretty clean so far. And when you want to get the list back, you can just split on these commas. Wherever you see a comma, that's where your new word begins. So when you do a split, what would happen? Data will be your first string, 1, 2, 3 would be your second string, and hello would be your third string. So this works because the given list of strings and our decoded list of strings are the same. This seems like it works, but here's where things start to fall apart. Now, instead of this string 1, 2, 3 here, what if I say the string is 1, comma 2, comma 3. This whole is one string, 1, comma 2, comma 3. This is possible. A comma can be a part of your string. So what if the input is this? Now if you do encoding and decoding, let me erase this. Now let us do the encoding for this part. You take data, use a comma for delimiter, then your second string comes up, 1, comma 2, comma 3, use another comma, and hello. This is your encoded string, right? Now when you decide to decode it, what happens in that case? You see a comma, that's where your new word begins, so you'll have your first string this. You see a comma immediately here. What happens then? Our decoder would think 1 is one separate string and it adds this. Then 2 as a separate string and 3 as a separate string and hello as a separate string. This is how our decoder thinks, and these two are not same, obviously. We've lost the original structure because the comma that we decided to use as a delimiter, it's not just a delimiter anymore. It's a part of your data. It's basically inside the data that we have, inside the string that we have, right? So it's not just commas. You can use any delimiter. You can use a slash, you can use a hash, you could use a semicolon, whatever. Anything that you use, it could be a part of your string. So you'll face this problem whichever separator you intend to use. So we realize that any solution that depends on finding a separate character, a separator, or a delimiter is not reliable in this case because we can't control what's inside the string. So now we have to ask ourselves, how do we encode the strings so that the decoding is always reliable no matter what characters are inside the string? That leads us to a better idea. Instead of looking for a separator, what if we just tell the decoder exactly where each string starts and ends? Take the same example that we have, data 1, 2, 1, 2, 3, that's one string, hello, and let us also test for empty strings. Okay, so this is our data now. Now instead of looking for a separator, what we can do is we can tell where each string starts and ends. So think about it. What's one thing that we always know about a string? Its length, right? So here's the better idea. For each string, we are claiming that we can tell the decoder that, I'll tell you the starting point and the ending point. You count as many characters as you want depending on that particular value that I'm giving you, and return that as a string. So in that case, the length of data is 4, and you mark it with a special marker, and then you append this string data. Now you may ask me a question. What if this value here, this string, is 4 data? In that case, the length would be 5, and you mark it with a special marker. So you know that this is the length, you're marking with a special marker, and then your string will be appended, right? You understand what's happening here? So that's what is going on. So similarly, you'll have to do, this is for the first string. Similarly, you can do for the second string as well. There are 5 characters in here, 1, 2, 3. So 5 hash 1, 2, 3. We are appending the string. Then you have a hello, which is 5 characters again, hash and hello. Then you have an empty string. So there are no characters, no length, it's an empty string. So all you do is 0 hash. That way, if you want to decode this, what happens if you want to decode this? What you do, you read the length first, and then you skip this special marker. You just read the length, skip the special marker, then read exactly that many characters, which is 4. So you read 4 characters, which is D, A, T, A. So our first string is done. Next comes 5. So what happens? You skip this hash and read 5 characters, which is 1, 2, 3. Then again 5 characters, skip the hash, so it is HELLO. And then finally you have 0 characters, but there's a word here, so it is empty. So this way you can get back the original list, whatever, even if the string has any special characters, any commas, any hash signs, any slashes, anything, empty spaces, it always works because we are not searching for anything. We are just reading based on the length of the string, and it is super safe. And just to add, this technique of using these length prefixes is actually how some real world systems work. Like major example is a network protocol, or it's also used in file formats. So now that the intuition is clear, let's talk about the performance. We're doing encoding and decoding. So for the encoding, it takes O of n time complexity, where n is the total number of characters across all the strings. And decoding also takes O of n because we read through every character just once. Now space complexity takes O of n as well because we are using a new encoded string and a new decoded list. So overall, it's an efficient algorithm. Now let's take a look at the code. Let's start with encoding. Now let's start by creating an empty string to build our final encoded result. Now we loop through each string in the input list, and for each string what do? We'll first calculate its length, then we add the length followed by a special marker, that is the pound sign, and then the string itself, and we can append everything to our encoded string because that's one string that we need to return. So let's do this. First calculate the length of that string and add the special marker, and then the string itself. But this length of string returns an int. It can't be integer because this is a string. So you can just convert this to string. Now encoding is done. Because all the strings would be processed at the end of this loop, you just return this. Now for the decoding, we decode the single encoded string back into a list of strings. So let's create that, and let's have a pointer to keep track of the position while we scan the string. Okay, now we continue scanning until we reach the end of our string, the encoded string. Now let's create another pointer to actually calculate the length of the word. Let's start at I. Now to calculate the length, remember for every string the first it is prefixed with the length, right? To calculate this length, what we'll need to do is we move this j forward until we find the marker here, pound sign, right? Until we find that. So something like we can do s of j. If this is not equal to the special marker, we just keep moving. But when we find the pound sign, we convert the substring from I to j as the length. So I to j. But this one is a string, right? But length, it's an integer that we need. So convert it back to an integer. Now once we found the length, what we need to do is after the marker, the next length number of characters, whatever we get in this length, those many number of characters will be our original string. So let us have two pointers here, start of the string and end of the string, right? Start would be j plus 1 because j currently is at the marker position, right? Now end would be from the start position plus the length of that particular string, and this start to end substring would be our actual one of the strings in our list of strings. So what we can do is we can just append the string from start to end. Make sense? Now one final step is we need to move our actual pointer, that is I, to the position right after the current string because we need to continue our decoding if there are more strings left. So just move it to the end position, and at the end we can just return this. So yeah, this should work, and yeah, this works. So it's a simple idea with a great real world application. So the strategy that we employed, it avoids all possible edge cases, and it's basically what someone looks for when you're designing reliable systems. So yeah, that's the problem. I'm currently working through the Blind 75 series, and if you are struggling with a lead code problem, or if you want a specific problem covered, drop a comment and I might cover it next. Until then, keep practicing, and I'll see you in the next one.